Hello everyone, welcome to Reactify Labs. Today we will talk about another topic called quorum. So, the literal definition of quorum is the minimum number of people needed to start a meeting. Okay, minimum number of people needed to start a meeting. And this is the same concept that's used in distributed systems. But here, instead of people, we have nodes, and instead of a meeting, it's a kind of like decision making. That's what generally happens in a meeting, right? So, if let's say the quorum is 7, means the minimum number of people required to start a meeting is 7, and if we have less than 7 people, then the meeting will not happen. And that's what happens in quorum as well. So, that's it. Now, I am pretty sure you have an idea of what we are going to talk about next. So, with that understanding, let's go into the theoretical discussions of quorum based systems. So, what are quorum based systems? So, quorum based systems are a distributed systems approach that leverages a quorum. So, you can see recursion here, right? Okay, so basically, it's a distributed systems approach that leverages a quorum. That leverages a quorum. Okay. And what is quorum? It's a subset of nodes. And why it leverages quorum? Quorum to make decisions. To make decisions or perform operations. All right. So what they do is they balance consistency and availability. They balance consistency and availability. So once we know that what quorum based systems are, and it's not very different from actual quorum, so now let's move to understand what quorum is in terms of our distributed systems. Okay, so quorum is basically a fundamental concept in distributed systems. Quorum is a fundamental concept in distributed systems, ensuring consistency and fault tolerance. Ensuring consistency and fault tolerance. It plays a crucial role in maintaining data integrity and system reliability. Crucial role in maintaining data integrity and system reliability. Okay, so here if you see, I said consistency and fault tolerance. You might ask, why not availability? It's a genuine question. It's a genuine misconception or a doubt that can occur here. But the thing is, if we have, let's say, multiple nodes, we don't need to do anything to guarantee availability. As if you recall, in availability, we don't need our data to be same. It is possible here data is D, here data is D1, here data is D2. Still the system is available, right? So what quorum does is it guarantees consistency, not availability. So for consistency we need quorum. I hope this clears it. Now there is something called quorum size. What is quorum size? It's the minimum number of nodes needed for a decision to be considered valid. Okay. Minimum number of nodes needed for a decision to be considered valid. Okay. And we have two types of quorums. One is read quorum and another one is write quorum. Okay. We represent read quorum as, let's say, R, write quorum as W, quorum as Q, and Q is basically read quorum plus write quorum, which is greater than n. N is the total number of nodes. So let's say if we have 10 nodes, so read quorum, if read quorum is 5, write quorum needs to be at least 6, because it should be, read plus write should be more than n. Okay. So this is the mathematical representation. Q is quorum size, R is read quorum size, W is write quorum size, and n is the number of nodes. Okay. So I believe, like, with the name read quorum and write quorum, it's clear what each of these do, but still let's talk about their technical definition. So read quorum ensures that a certain number of nodes must agree on a read operation. That a certain number of nodes must agree on a read operation for it to be considered successful. So let's say if we have different nodes, and different nodes, it is possible that may have different data. So if this node reads something, this node reads something else, this node reads something else, so which one is correct? That one is correct which R number of nodes read. Okay, read quorum size. So generally R is given by total number of nodes plus 1 divided by 2. Okay, so if we have, let's say, 5 nodes, so R would be 5 plus 1 by 2, it means 3. So if we have 5 nodes, so if 3 of the nodes have the same value, they read the same value, that value is considered to be the latest or fresh or whatever you say it. So that's the read quorum, that's the correct value. Okay. Next, there is something called write quorum. So write quorum says that, again, just like read quorum, write quorum ensures that a certain number of nodes must agree on a write operation. For it to be considered successful. Okay. And W is given by n by 2 ceiling value plus 1. So for 5, it would be 5 by 2 plus 1, which is basically 4. because 5 by 2 is 2.5 and ceiling value of 2.5 is 3. So 3 plus 1 is 4. So if we have 5 nodes, then at least 4 of the nodes should agree on one value before it gets written, before it's considered as a valid write. Okay, great. So now we know that, okay, different nodes will agree and it will be like quorum something something something, but how do we ensure that all nodes are consistent? How do we ensure that what different nodes are saying, they know what they are saying, or each other or other nodes know about what the other node is saying? Okay, so for this what we have is called quorum consistency. So quorum plays an important role in maintaining data consistency within distributed systems. Okay, by requiring a majority of nodes to agree on operations, it ensures that the system state remains coherent, right? Okay, means there will be different nodes which will agree on something. Great. Uh, what exactly is quorum consistency? Quorum consistency means different nodes need to agree on one thing. Okay, as we say, yes, this and this agree that, okay, this is the value we have to read or this is the value we have to write, and that is what we call quorum consistency. Where exactly are these things going to play, or quorum consistency going to play an important role? The first one would be conflict resolution. Conflict resolution. So consider a scenario where two nodes attempt to update the same piece of data simultaneously. Okay, there are two nodes and both of them need to, let's say, update a database from A to B. Which value will be the right one? Okay, if let's say, sorry, this one tries to do A to B and this one tries to write A to C, then which one is correct? Quorum ensures that only one of these updates is accepted, thus preventing conflicting changes by requiring a majority vote, allowing only one update to proceed. So when there are multiple nodes, it will ask everyone else, what do you want to write? It says C, it says B, it says C, let's say it says C and it says B. Let's say there is one more node which also says C. Now you know that, okay, we have a quorum, 6 nodes, 4 nodes say C, it means this write will be accepted, right? So that's where conflict resolution happens in quorum consistency. Next is data replication. Next is data replication. In distributed systems, quorum ensures that replicas of data across nodes remain consistent. And that's what quorum is about, right? Even in the face of concurrent updates, this should happen. Quorum ensures consistent data replicas by requiring agreement among a majority of nodes for the updates, as we discussed. So majority of nodes are there, sorry, number of nodes are there and majority of them need to update, need to agree on something, and that's where quorum plays an important role. Okay, and that's where our data replication can also happen uh, without having inconsistencies in the data. As we saw in our previous video about database replication, we do data replication, but what are we going to read or what are we going to write? For that we need quorum. Okay, so if you see, all the lectures are interrelated. They may be used in one way or the other, or one may be helping the other. In the previous video I talked about how database replication works. Yes, we have master slave architecture. Yes, we have master architecture. Different masters need to write on something. Or we have peer to peer architecture where everybody is a master. So which value is right? Which one is using the latest value? Quorum. Quorum is going to help in that, right? So I hope now you are slowly able to see the picture of how this entire playlist of system design concepts is related to each other. If you try to think of any system, you will see each of these concepts are going to be used in one way or the other. Okay, Great. Now, there is one problem with quorum. Not one problem, um, something, yes, you can say it as a problem. And the problem is of fault tolerance. Or, yeah, let's say we have multiple nodes, okay, and let's say one of them fails or two of them fails. What happens in that case? Hmm? So, about that, I will talk about in fault tolerance. Fault tolerance. Quorum significantly enhances fault tolerance. So even if multiple nodes fail, quorum enhances fault tolerance by allowing system operations to proceed seamlessly. By allowing system operations to proceed seamlessly, okay, even when network failures happen. This resilience ensures the continued reliability of distributed systems. If we talk about examples, let's say there is a node failure. One node is failed. If one node is failed or it becomes unresponsive during a critical operation, okay, quorum mechanisms enable the system to continue functioning by considering the agreement of remaining operational nodes. Okay, so let's say we had 6 nodes, two of them are down. Quorum will still work, but now the n becomes 5, and that's when we'll agree or disagree on whether to read or write a particular value or not. Okay. Next is network partitioning. Network partitioning. So in case of network partitions, when communication between nodes is disrupted, quorum ensures that the system can still make progress by requiring agreement among reachable nodes. Okay, similar thing, just like previous. Let's say this is not reachable, this is not reachable. Then whichever are reachable, only those nodes are going to take part in the quorum, in the decision making, and the updates are going to happen. So that's how quorum also takes care of the fault tolerance. Quorum makes sure that it provides fault tolerance mechanism. Even though multiple nodes go in failure state, still quorum works fine. Okay. So I think in the beginning of this fault tolerance, I said it's a problem with quorum. No, it's just basically a problem quorum solves. Okay. But yes, quorum itself is not free of problems. So let's see what are the issues with quorum. Issues with quorum. First one is data availability. One challenge with quorum is the potential for reduced data availability. Why? Why reduced data availability? Let's see. Let's say we have 5 nodes. Okay. This one needs to write A, this one needs to write B, this one needs to write A, this one needs to write B, this one needs to write A. For 5, for n equal to 5, we know that write quorum is 4. And here, the maximum value that we have is 3 for A. 3 nodes want to write A. So this will not be written. And that's where data availability is questioned. Because the required quorum size is not met, we are not going to write any value, either A or B. We don't know which one is correct, right? But majority of nodes agree on A, but still it's not majority enough. We need at least 4. So that's when data availability becomes an issue. Okay. Second is latency. Achieving consensus with quorum may introduce latency, especially in scenarios where nodes are geographically dispersed. So if we have nodes which are dispersed across the globe, then everybody needs to talk to everybody and they need to know that, okay, what value do you want to read or write. So it is possible that this is very far. Let's say this is in Australia, this is in US. Then this traveling of data from each other will take too much time, and which introduces latency. Okay. And next is complexity. Why complexity? Implementing and managing quorum-based systems can be complex, requiring careful consideration of factors like network considerations and node failures. Network considerations and node failures. Okay, so because there are multiple nodes, each of these need to communicate with each other, and we don't know about what the network situation will be or is at current time, and different nodes are there, different kinds of situations exist at different places, so node failures can be there, network partitions can be there, power outages can be there, so it introduces a lot of complexity. Okay, great. Now we know that there are different issues with quorum. What is the solution? Is there any solution, or is there something which we can do to relax this quorum? So yes, there is something we can do. For example, let's say we have uh, 9 nodes. For example, 1 2 3 4 5 6 7 8 9. Okay, so if we have 9 nodes, what is the read quorum size? It was 9 plus 1 by 2. Okay, so which is 5. 5 is basically more than 50%. So R is 5. And what is W? N is 9. W would be 9 by 2. W would be 9 by 2 ceiling value, which is 5 plus 1. Basically this is 6. So right quorum is 6. So if right quorum is 6 and read quorum is 5, what do you think is right here? Like, we need 6 nodes to agree before writing anything. We need 5 nodes to agree before reading anything. It's very strict, right? Even if we have less than 5, let's say we have 4 reads, or we have 5 writes, the read and write will not be considered valid, right? So this is an issue with quorum. Quorum is very strict. So to solve this, we have something called sloppy quorum. What is sloppy quorum? Sloppy quorum is an approach that relaxes the strict quorum. It relaxes the strict quorum requirements. It relaxes the strict quorum requirements and offers a solution to some of the challenges faced with traditional quorum, right? Basically, it relaxes the strict quorum requirement, and that's how it solves the problem of traditional quorum. So unlike traditional quorum, sloppy quorum allows for flexibility in the number of nodes. In, like, for example, here in traditional quorum, there is no flexibility. Like, you need to have at least 5 or at least 6. In both the cases, if you see here, it's more than 50%. Here it's more than 60%. Basically, it's 66%. So which is too much. And it allows for flexibility in the number of nodes needed for agreement. Okay, thus providing a more adaptive and fault tolerant approach. What? Adaptive and fault tolerant approach. In traditional quorum, we have a strict requirement, right? We have a strict requirement like read. Read would be total number of nodes by 2 and something like this. Read and write, whatever, you know. But sloppy quorum, what it does is it introduces a flexibility factor. Sloppy quorum introduces something called flexibility factor. So if we have number of nodes as 9, so read quorum size can be 9 by 3, which is 3, 2 into 9 by 3, which is 6. So read quorum can be anywhere between 3 to 6. So if we have 4 9 nodes, then even if these 3 agrees, it will be read. It's a valid read. 4 agrees, it's a valid read. 5 agrees, it's a valid read. So if you see, it's 33%. So anywhere between 3 to 6, it's a valid read, right? Similarly for write also, there is a range basically. We establish a range, and that's when we say that, okay, this is what we need. At least this is what we need basically. So it's not that if we have 9 nodes, all 9 agree on reading something or writing something, it will be discarded because it's more than 6. No. So what it does, it basically establishes a lower bound, or lower bound. At least these many number of nodes should read or should write, should agree on a read or should agree on a write. Rest we don't know. Okay, at least it's at least. Actually, yeah, it just relaxes the number, relaxes the range, or the relaxes the lower limit. So this flexibility enables the system to adapt to varying network conditions and node availability. This flexibility allows the system to continue functioning even if only a subset of nodes is available. Okay, even if a subset of nodes is available. We don't need all nodes to be available, or strict requirement as traditional quorum. So let's say traditional quorum wanted 6 nodes, but here we say not 6 nodes, we need 3 to 6 nodes. And if 3 nodes agree, we are good. If 6 nodes agree, great, but we are good with 3 as well. Okay, so that's what sloppy quorum does, and this concludes our quorum. I hope I have explained it enough in great detail, in as much detail as possible. It was to explain quorum and try to understand these concepts with what I have taught in previous videos. Also try to link them together, how one is used in other, or how one can be used in other. Okay, so that's it. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.